All right, we are going to talk about a couple of things in this video. It should be short. First thing is standard temperature and pressure, also referred to as STP. Okay. When a gas is at STP, that means we've made temperature and pressure the same, so that if you were to publish, say, and somebody in a different country were to read your work, and you're reporting on a volume of gas, let's just say, and you would normalize everything to standard temperature and pressure, so everything would be the same. Because if you conduct an experiment on gases at different temperatures and pressures, you will get different volumes for your gas. So STP is just a universal temperature and pressure. And it is 0 degrees Celsius, of course, that's 273 Kelvin, and 1 atmosphere. That's what standard temperature and pressure means. So anytime you see a problem that says the gas is at STP, that is exactly what they were referring to. So now, let's move on and let's talk about molar volume. Okay? And specifically, we're going to calculate the molar volume of a gas at STP. And you can calculate the molar volume of a gas at any temperature and pressure you want. Just follow the same steps. But molar volume of a gas at STP is kind of another one of those universal things that all chemists kind of know. Excuse me. So we have PV equal to nRT. Well, I said we want molar volume. Molar volume, what's that? It's not the volume of your tooth, okay? It's the volume of 1 mole. So molar volume is equal to volume divided by moles, volume per mole, right? So now all we have to do is take PV is equal to nRT, get N, let's divide both sides by N, and let's just at the same time divide both sides by P, just so we can do this in one step. And we get V over N is equal to RT over P. And that, all we have to do is plug in standard temperature and pressure here. We get 0.08206 liters times atmospheres divided by Kelvin times moles, all times 273 Kelvin over 1 atmosphere. And let's look at the units. Atmospheres go away, Kelvin goes away, and what are we left with? Liters over moles, okay, molar volume. So we get 22.4 liters per mole. And what does that mean? You can use this as a conversion factor for stoichiometry. As long as everything is at STP. Oh man, I forgot what I was going to say. Oh, another thing is, this is the volume of any ideal gas. That's something I didn't talk about, is what we call an ideal gas. I keep forgetting to talk about that. An ideal gas obeys the kinetic molecular theory of gases. Okay, so anything that has tiny, tiny particles, doesn't attract or repel other molecules, Kelvin temperature is proportional to the velocity of the molecules, all that sort of stuff, that is an ideal gas. Okay, guess how many ideal gases there are in the world? I would say approximately 0. Okay, but there are 2 that I obey most ideally, and we'll talk about this later on. But H2 and HE obey the most ideal. That is, their behavior most closely matches the ideal gas law and all the tenets of the kinetic molecular theory. However, they're not perfect. But because they are such small molecules in the case of hydrogen or atoms in the case of helium, they do pretty well. We will talk about things that don't obey the ideal gas law in KMT later.